Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss the notion of continuity. A function is continuous if you can draw it without picking up your pencil. This is the intuitive definition of continuity. For example, this would be the graph of a continuous function. There are no holes or breaks, and so it's continuous. Whereas if I did something like this function would not be continuous at this particular x value. For example, if this is the y-axis and this is the x-axis, and maybe this is 2, then we would say the function is not continuous at 2. So continuous basically means you can draw it without picking up your pencil. Not continuous means it has some type of hole or break in the graph. More precisely, a function f is continuous at a if the following three conditions are satisfied. First is that the function is defined at a, so f of a is defined. Second is that the limit actually exists, so the limit of f of x as x approaches a exists, means it's equal to a number. And the third is that the limit of f of x as x approaches a is equal to f of a. Let's go ahead and do some examples using this definition so we can determine if functions are actually continuous. So here is our first real example. Is f of x equal to 3 over x minus 2 continuous at x equals 2? Let's go ahead and answer this very carefully. Solution. So when you're trying to find out if a function is continuous at a particular number, you want to fall back on that definition. So the first condition was that the function was defined at a. In this particular example, a is equal to 2. So we have to look at f of 2 and see if this actually makes sense. Well, when you plug in 2 into this function, you get 3 over 2 minus 2, which is equal to 3 over 0, which is undefined. You're not allowed to have 0 in the denominator. So condition 1 fails, so the answer is no. It is not continuous at x equals 2. This example is a little bit more challenging, but also more interesting. Is the function continuous at x equals 1? And we're given a piecewise function. It's f of x equal to 3 if x is less than or equal to 1, and x plus 7 if x is greater than 1. Let's go ahead and work through it. Solution. In problems like this, you want to basically go through each of the conditions in the definition of continuity and check them very carefully. So the first condition is to check that the function is defined at a. In this particular problem, a is just 1. It's our x here that's given. We're looking at f of 1. Now we look at the different conditions for the piecewise function. It looks like the top condition is the one that is satisfied when x is 1, because if you plug in a 1 here, it's true, right? 1 is less than or equal to 1 because it's equal to 1. So this is equal to 3. And so the first condition checks. F of 1 is defined. That means that it's equal to a number. So we're good. The second condition is that the limit of f of x as x approaches 1, it needs to exist. Because we have this piecewise function with inequalities, in order to compute this limit, what we're going to do is we're going to compute the one-sided limits. Recall that if the one-sided limits exist and are equal, then that is the value of the regular limit. If the one-sided limits are different, then the regular limit does not exist. Let's just go ahead and work through it and evaluate these one-sided limits. Let's start by taking the limit from the left of f of x. So this is equal to the limit as x approaches 1 from the left. And we need to figure out what goes here instead of f of x. Like, what do we actually put here? To do that, you look at this condition here. X is approaching 1 from the left. That tells you that x is less than 1. That tells you that we're going to be using the top condition. So we replace the f of x with a 3, and we have the limit of a constant, so we just get the constant 3. Now let's take the limit as x approaches 1 from the right of f of x. So this is equal to the limit as x approaches 1 from the right. And again, we have to figure out what do we put here in place of f of x. Because x is approaching 1 from the right, that means x is larger than 1. In other words, it's greater than 1, which is exactly the second condition here in our piecewise function. So we use the bottom piece, which is x plus 7. Now we can evaluate the limit. That means we plug in the number, drop the limit sign, and we get 8. I want to emphasize the notation here. Notice I wrote the limit sign every single time until I took the limit. It is super important to do that. One of the most common mistakes people make is that they don't write the limit sign in these problems. So very, very important to be very careful in your work. So the limits are not equal. So let's just specify that. The limit as x approaches 1 from the left of f of x is not equal to the limit as x approaches 1 from the right of f of x. So that means that the regular limit does not exist. The limit as x approaches 1 of f of x does not exist. D&E means does not exist. So because the limit does not exist, the answer to this question is no, the function is not continuous at x equal 1. I want to highlight two very important facts. It's actually like 20 facts, but I've broken it down so it's just two. Basically, all the functions you know are continuous as long as they're defined. So polynomials, rational functions, root functions, exponentials, log functions, trig functions, inverse trig functions, they're all continuous in their domains. In other words, as long as they're defined, they're continuous. Second one is that the sum, difference, product, quotient, and composition of continuous functions is also continuous, as long as, of course, everything is defined. So if you add continuous functions, you're going to get a continuous function. Let's do several examples using these two important facts. The question is, where is the function continuous? So in part A, we have a function f of x equals x squared plus 4 minus e to the x plus 1 over x. Let's go ahead and just work it out and write down the answer. So we're going to use what we talked about earlier. So this is a polynomial, x squared plus 4, so it's continuous. E to the x is an exponential function, so it's continuous. When you subtract them, the whole thing is continuous. So all of this right here that I'm putting in a box is continuous because it's the difference of continuous functions. 1 over x is continuous everywhere it's defined. The only time this is not continuous is when x is 0. So basically, this whole thing is continuous as long as x is not 0. So the answer is it will be continuous everywhere except 0. So you can write that in interval notation as follows. It would be negative infinity all the way to 0, parentheses union, parentheses 0 to infinity. This is basically every single number except 0. Part B is g of x equals cosine of x squared minus x to the 10th. Let's go ahead and work this one out. Solution. So cosine itself is continuous, and so is x squared. The cosine of x squared is basically a composition of continuous functions, so it's continuous. X to the 10th is also continuous, and when you subtract two continuous functions, you get a continuous function. So the answer here is everywhere. You could write the answer as negative infinity to infinity. So there's no issues here at all. Basically, when you look at these problems, you want to ask yourself, is there anything funky going on? Am I dividing by 0 in any case? Or is there anything weird with square roots? In this case, we saw we had division by 0, so we threw away the 0 and wrote the answer this way. In this case here, we had no issues, so the answer was all real numbers. I want to finish this video with a really interesting example. The question is to use continuity to evaluate the limit, and we have the limit as x approaches pi over 2 of the cosine of x plus cosine x. So if you recall in the definition of continuity, third condition said that the limit as x approaches a of f of x is equal to f of a. In this particular case, if we look at this function, we know x is continuous, we know cosine x is continuous. The sum of continuous functions is continuous. So this piece here on the inside, x plus cosine x, is continuous. Cosine x on the outside is continuous. We have the composition of continuous functions, so it's continuous. Basically, this entire thing is continuous. So this is actually equal to this function evaluated at pi over 2. So if you think of this as your f of x, this should be equal to f of pi over 2, which basically that means that you can just take the pi over 2 and plug it in for the x, which is something we've been doing all along. So this is the cosine of pi over 2 plus cosine of pi over 2 parentheses, parentheses. Basically, in this definition, our a is pi over 2. So the limit as x approaches a of f of x is f of a, but again, a is pi over 2. Cosine of pi over 2 is 0, so this is the cosine of pi over 2 plus 0, and this is equal to the cosine of pi over 2, which again is just 0. And that would be the answer. I hope this video has been helpful to you. Good luck.